Good evening, everybody. Welcome to tonight's edition of the Triangle Area SQL Server User Group's Advanced DBA meeting. We are in the second week of March, the second Tuesday to be more specific, and we have the pleasure of hosting David Klee, who's going to talk to us a little bit about performance tuning in the virtual world. And Anders is here to heckle, so welcome in, Anders. But with that, I'm going to hand it right off to you, Mr. Klee, and take it away.
Sweet. Sounds good. And Anders, if you're out there, feel free to heckle at any time. If anybody has any questions at all, please feel free to shout, yell, scream, interrupt, whatever you need to do to get my attention and have me stop blabbing up here so I can answer your question. So this is virtual SQL Server performance tuning. Now, virtual has a lot of meanings to a lot of different people out there. I always joke that, cloud is nothing more than somebody else's data center with some really good automation in it. So everything that I'm talking about here directly applies to public cloud as well as everything on-prem. There may be a few areas that we may not have direct access to in the cloud, but all of it still matters. So let's get rolling. If you've never seen me talk before, I am a nerd, and my hair is about 2 feet longer than that photo at this point. My name is David Klee. I am the founder, and you can call me head nerd, of Heraflex Technologies. Contact info is up on the screen up there. I'm also lucky enough to be a Microsoft Data Platform MVP and a VMware vExpert. We have fun playing with a lot of big toys and run my own consulting company. And what you're getting today is arguably a lot of the tips and tricks that from a consulting engagement, a lot of people pay for. These are just a lot of the common challenges that I see all over the place with virtual SQL servers and just dumb defaults or infrastructure admins that aren't really aware of the SQL Server internals and the impact of a lot of their challenges. And I just have a lot of fun tuning this stuff. So SQL Server is arguably one piece of a much bigger puzzle. It's not the most fun, but it's the thing that stores all the data, but there's so much stuff around it and underneath that all have to line up. We've got an operating system. Even if you're in a container, you still got an OS underneath. You've got the platform that it runs on. So there's a hypervisor in there somewhere. Now, if you're still bare metal, a lot of this still applies as well. You've got enterprise storage underneath, and you've got how everything communicates and talks. There's just a lot of pieces to it. But from my perspective, the data is, to be cliche, it's what a lot of companies treat as oil. It's literally the thing that's the most important, critical thing to an entire company. It's part of why I spend so much time tuning this. Now, it's the 21st century. It's 2023. Hypervisors at this point are arguably the new beige. VMware is the one that's been around the longest, but Microsoft Hyper-V's there. There's everything based off of KVM. So, Red Hat, Oracle, VM, Zen Server, all that kind of stuff. There's Nutanix that's got their own Acropolis hypervisor. I have personal preferences. I don't have professional preferences anymore. These things work. They're comfortable. There's low overhead. They just work. And by the way, this stuff powers the cloud. It's here to stay. There's really no reason to not be virtual at this point, no matter if you're on-prem or in the cloud. Now, VM is arguably just the assumption, but some people out there are still holdouts for this stuff. And I always joke that if you design this stuff right, if you use it correctly, and if the people managing the stuff can actually keep up with it, there's absolutely no reason to not be a VM at this point. But everybody's got to be on board with how to manage these things. It's not just another workload. We have high memory requirements. We have high CPU demand. We have low CPU latency requirements because we've got to keep this thing fast. We have high burst storage demand. And we have very stringent latency requirements in order to keep this thing quick. This is not a normal workload. This is a very serious enterprise application. And unfortunately, a lot of your infrastructure admins may not be on board with this. They may not know. All they know is it eats all their CPU and kills all their storage and crushes all the memory around it. And they may complain about that. I even had an infrastructure person yesterday say, yeah, your SQL Server is eating a lot of I/O in the middle of the night. Can you stop that? It's like it's part of a backup. Can't exactly change that too much. Now, in a lot of my consulting, I've been consulting around this stuff for about 13 and a third years at this point. I've been a practitioner of SQL Server and VMs for another 10 prior to that. So I've literally been doing this since 2000. Yeah, I'm that dork. There are trends and patterns that you see with how a lot of these things can be misused. So item number one, not having a baseline. This is big. CPU presentation on these virtual machines matters, on-prem, in the cloud, wherever. Right sizing is a really big thing that is missed, not just for SQL servers, but for anything. Hypervisor storage level queuing is another really big one. And then virtual machine disk presentation just kind of rounds it all out with all the things that we as DBAs can specify and we can tune and we can get in front of a lot of the stuff, even if we don't have direct access to a lot of the components of the hypervisor underneath. So item number one, baseline. And I know everybody out there is just groaning at this point, because when I always ask a question, how many of you know exactly what your SQL servers are supposed to be doing right now? There are very few people that would raise their hand and say yes. I use a baseline to give me a standard. What is this machine supposed to be doing right now? Now, there's CPU, memory, network, disk. And then there's application level items like transactions per second, page life expectancy, all these other things. They all tell me bits and pieces of a bigger picture. It's literally, what are you using? What's the traffic patterns like? How's the underlying platform responding to the demand? And you can see this depending on which indicator is in there. Now, it's tough because when people call me for consulting and they use the magic phrase, it's slow, I always ask, well, what's it doing when it's running well? And nobody ever has an answer. And it's hard. Now, there are third-party tools that can do this. Some of them are okay. Some of them, a little iffy. You got to be really careful, though, because a lot of times what they'll do, they'll give you a point in time data, a snapshot of data, and they'll call it a baseline. No, I need to know what a normal day is. And when you start to actually get a sense for what a normal day looks like, now we can turn around and say, okay, well, with the real-time data from a lot of these really good monitoring tools, what's it doing right now? And is that normal compared to what is normally occurring at this day in time? And that's hard. Now, when we go look at how these things are built, we have CPUs, we have memory, we have hard drives, and none of this is specific to on-prem or in the cloud. If you're building virtual machines or deploying databases as a service out there, you still have to worry about this stuff. I mean, you build a VM in the cloud, you specify the amount of CPUs, you specify the amount of RAM. Now, they come along with the series and the scale. Data disk, same exact thing. I still need to know what this stuff is doing. And if you're in any of the X as a service, usually they've got some basic telemetry in there for you. You still got to get into this stuff. The way I like to do it, if it's a Windows machine, you can capture Windows perfmon data and record it into a database. There's a PDF, there's no contact info required out there at this link, and that tells you how to set up perfmon the way we like it. It's got all the counters that we care about in there. And then if you want to get your hands dirty with this stuff, out of GitHub, published a PowerShell script that will take those BLG files that perfmon creates, a binary log file, and it loads it into a SQL server for you. That's going to give me the data in the format that I care about. You can import it nightly. It's nice and straightforward. So now you have the data in a raw format. So quite literally, any of the tooling that you care about, so even just raw T-SQL, Power BI, SSRS, whatever you want to use, you've now got a lot of this raw data, and you can take this and start to trend it. Now, out at that GitHub site, there are some examples of ways to actually not just look at a point in time of the data, but start to come up with a time-sliced average or percentiles and do it over time. And you can start to figure out what a normal day actually looks like. Now, item number 2, virtual CPU presentation. And this is a big one. This is one that I probably spend 10 to 15 hours a week cleaning up on behalf of customers. We got to be careful. So if you do CPU's presentation incorrectly, you are going to get burned. By the way, this was a $250,000 piece of equipment that when you study electrical engineering, there's this old adage that electronics are all powered by smoke, because when you let the smoke out, it doesn't work anymore. That's exactly what happened to this machine. Not a lot of fun. So virtual CPUs, in my opinion, is arguably the most piece of the SQL Server VM config, and that's because that's what your licensing is based out of. Arguably, it's the most expensive thing to get wrong. So if you don't do it right, you're going to end up spending a ton of your company's cash. You may not see it or feel it, but if you can cut some of the stuff down, the right people are going to notice. We got to be careful. Now, when we look at server grade equipment in most data centers today, we got two manufacturers to pick from. Intel is the one that's what you're probably going to find in your servers. AMD has been making a series of chips recently called the EPIC processor line, and I can tell you comfortably, I love these things. They are fast, they're efficient, and they're the same price as the Intel stuff, but per core, they're quick. Now, how do we dive into this stuff? So first of all, let's get some terminology down right. The CPU package is what a lot of people call the processor or the chip. It's basically this collection of CPU cores that goes into a mainboard socket. We'll look at that here in a second. In this package, you have one or more CPU processing cores. Each one of them have a little bit of cache memory. So level 1 cache, level 2 cache, and then there's usually some shared cache called last level cache or L3. There's a bunch of other junk in there, and because of marketing, they call it the uncore. It makes perfect sense, right? In there is one thing I really want you to be aware of, and that's a thing called a memory controller. We'll touch back on that again here in a minute, but it's per CPU package. Now, you zoom out a little bit. Here's our CPU topology. So that's your main board. That's the thing that everything connects to. So memory, network adapters, all that kind of jazz. In that main board, you may have one CPU package socket. You may have two. You may have four. Some of the older machines from HPE would do 8. If you look at how some of these things can scale, there's a computer out there right now with 32 CPU sockets, and it's a bear. Do I wish that on anybody? No, but it's super cool when it works. Now, everybody that I know, they base what they purchased on core count and clock speed. Clock speed is not everything that we care about. Clock speed matters a fair amount, but the cache memory, the interconnects between sockets, all that stuff adds up. So there's a tool out there that I really, really like called Geekbench, and Glenberry will definitely agree with me on this one. I want to know a real world speed number. I want you to run this benchmark. It's completely free with an asterisk. If you use the free version, it sends anonymized results from your CPU make and model, how much memory you have, and the results. It sends it to a publicly addressable database that's available for you to go look at browser.geekbench.com. So you can actually go pull this and look up individual CPUs that you may be interested in. Don't look at the total multi-core score, because if somebody's got a physical machine with, let's say, 32 CPU cores on it, but they built a VM and they tested 4, that multi-core score is going to be skewed. Look for the single core number. Higher is better. There's no unit of measurement to it. But if we start trending this and we start looking, I can look at relative speed differences between individual CPUs. And if you're looking at upgrading, it goes a long way. So if we take a look at some of the better CPUs that are out there, and a few that I see in a lot of places, you've got a 3.1 gigahertz Xeon Gold 6346. Great. Value of 1,043. Start inching your way up. Xeon Gold 62 or 6354. And then we've got some of the general workhorse machines that I see in a lot of places. Xeon Gold 6230, Xeon Silver 4214. They look okay, but they're not that fast. When we take a look at this EPIC CPU, and that's a 3rd generation. The 4th generation just came out. And we got a client that's got one of these coming in 2 weeks, and I'll be able to benchmark it and update this slide with that. If you notice, it's per core. That's faster. So if we look at the Gold 6346 versus that Epic chip, that's roughly 35-40% faster per core. And if your SQL Server licensing is based per core, wouldn't you want to get the most out of that? And then start thinking about parallelism. I looked at one today. I'm not exaggerating these numbers. They had 226 CPU or 226 queries that went parallel in the last month. They had 2.1 million that went single-threaded. So single-threaded speed matters here. So if you can pick the CPUs that get you the best bang for the buck, don't you want to go with that? And it might mean that you have a dedicated VM host cluster to squeeze the most out of this. This is something that's a big point of contention with VM admins. So tread carefully. I'll provide the slide deck for you to review. Feel free. If you want me to jump on the phone, no strings attached, no marketing, no anything, and talk to infrastructure admins on your behalf about why this is so darn important, I'd love the opportunity because these things matter. Now, it's not just an on-prem thing. If you take a look, let's say Azure D series, look at this. If you just look it up on their knowledge base, it's a 2.3 gigahertz Intel Xeon E5 6373 V4 CPU. Guess what? Anything that's got an A in the name, like EA-6416, all that stuff, those are AMD chips. And if we start taking a look at the raw speed, if you're going to the cloud, guess what? Maybe 5% more for the virtual machine with that AMD chip in there, but it might be 20% faster per core. You just bought yourself more time on buying SQL Server licensing. That's a big deal. Now, we zoom out a little.
Sorry, there's a question in chat, kind of a baseline question around the scenario here specifically is Azure, but I think that would apply to AWS as well. But sometimes your VM gets moved to a different host. How do you reset your baseline after that? I've seen huge differences with the same SKU.
That's a great question. The hard part is you may not know when the VM moves. So that becomes honestly you run a baseline week by week. If you start to see patterns in there, see if you can find trends where it was at versus where it's at right now. Maybe you can figure out when it moved and then look before and after. And yeah, I mean, you look at any of the cloud platforms, these VMs move around all the time. May be interesting when you figure out where things are at. Cloud won't tell you when VMs move. If you're on-prem, they definitely can. You got to get into the hypervisor somehow. But it can tell you. But if you're in the cloud, it goes back to revisiting that baseline and looking for a change in state. It's not fun.
Got it. Thank you.
Now, let's zoom out a little bit from the individual CPU package. And there's this thing called NUMA. Now, this is non-uniform memory access. So the way it used to be back in the day, you got a CPU, you got memory. They're directly connected. Life is good. Simple. Over time, core counts went up. Socket counts went up. Memory density went up. And that thing in the middle that connected everything started to become a bottleneck. So in the early 2000s, AMD pioneered it, Intel perfected it. They came up with this thing on the x86 platform called non-uniform memory access, or NUMA. What they did is on the main board, you will have a CPU socket and memory really, really close to each other on there. So now if we take a look at this diagram right here, you can see that the CPU package contains its own memory controller. Instead of being off-boarded as a separate component on the main board, memory is now really close to a socket. So CPU package 0 can access the memory on CPU package 1. But if it has to jump over, it's now got to go through these interconnects to the other CPU, to its memory controller, to the memory and back. And it can slow down the request. Now, how much depends on the platform, the speed, and all that jazz. Most of the time, it's not that bad, but it's still measurable. I just don't want it to be noticeable. What I care about is for your workloads, can we essentially make sure that your SQL Server is either pinned, essentially, to one of these so that the memory and the CPUs are very local, or if it's bigger than one of these, it's got this awareness of the split so that the database engine can actually handle it properly. And this is where things get interesting. So if we look on a top-down diagram of a main board here, that is what we call a NUMA node, usually. Sometimes some of these CPUs, the physical package can have multiple NUMA nodes on there. It's called cluster on die or sub-NUMA nodes. For all intents and purposes for this discussion, I'm just going to say they're one and the same, but just know that on some of these newer CPUs, you can have sub-clusters on there. Most of the time, it doesn't really change anything with how we architect the stuff, but it's good to keep in mind. Now, in a virtual world, we need to make sure that this awareness is extended from the physical machine through a hypervisor, through the virtual machine, so that your applications can detect this. Because SQL Server is very NUMA aware, and what it can actually do is move memory around to make sure that the CPU and the memory to fulfill a query is actually in one spot. So in this case, you as a virtual machine admin or working with your team on this, you have the ability to say, here's the number of virtual CPUs that I want. Here's the cores per socket that I want. And in new versions of VMware specifically, you can detach the NUMA node from cores per socket. So you can go all the way into this cluster on die setup and make sure that your virtual machine topology mirrors and matches what's on the physical machine and get the most CPU horsepower out of the thing. You have to be careful with this. VM admins don't know this. When they go and create a VM, they're just saying, hey, you asked for 8, you get 8. They're not looking at this stuff. You got to be careful. Now, what we need is a right-sized vCPU count. We'll talk more about that in a second. But the rule of thumb is essentially if your virtual machine CPU count is less than or equal to what exists physically, not logical, but physical, in one physical socket, then build the VM for that number of cores and that amount of RAM. The memory matches or needs to fit as well, but the hypervisors don't do as good of a job looking at that stuff. If the VM won't fit, so let's say I need a 16-core VM, build it for 2 sockets, each with 8 core. 8 fits inside 12 just fine, so does the memory footprint. Life is good. And that's how you do it. You can verify this, and you should go verify this. Literally, get in a SQL Server. If you want the GUI, expand or right-click on the instance, hit Properties, expand Processor, expand NUMA node. You can see exactly how many NUMA nodes and cores per socket that SQL Server is seeing. If you want to do it in the DMVs, it's really easy. Select Stuff from sys.dmos nodes. What I'm really looking for on here, do we have anything listed as offline? Hope not. We have a different scheduler account per node. And if automatic soft NUMA kicks in, which is where SQL Server goes, guess what? You've got more than 8 cores per socket. So I'm going to subdivide this for you. You may actually have an imbalance in there. And if something lands on the wrong NUMA node and it needs to go parallel, you may not have as many cores for it to work on. So you got to be careful with that. Part of the reason to be really, really picky about this is SQL Server in Windows Standard Edition have NUMA limits. So it seems crazy, but in production, I've seen this just over and over and over again. And VM admins don't know. They're like, well, here's 12 sockets with 2 cores per socket. Windows and SQL Server Standard Edition can address up to 4 sockets or 24 cores, whichever is lower. I've had it go from bad to worse, where SQL Server could only use half the cores that it was assigned to. But then Windows wasn't using the same cores that SQL Server settled on. So they were duking it out, and CPUs were almost at 100%, and SQL Server was dog slow. You got to get this right. Now, how do we figure out the core count? And VM admins don't really understand this topic too well. So I'm going to see if I can break it down for you. Every single thing in a virtual machine, be it on-prem or in the cloud, has to be scheduled for virtual machine scheduling queues. Literally, every virtual CPU, every bit of memory, every storage access, all this stuff, and you click the button, you think it just works. It's not like that. everything has to go through the hypervisor scheduling queues. So there's a little tiny bit of time related to getting that command onto that scheduling queue. Now it's tiny, but it's still there. And then, depending on how active this stuff is, it may just sit. And this amount of time, the hypervisors call ready time or CPU wait time per dispatch, or you pick the terminology, but it's all the same thing. It's there and it's ready to run, but the hypervisor isn't ready for it yet. Then it starts running, but that doesn't mean it's going to stay running. It can get interrupted a lot. And it can go into different wait states. So it can go from a runnable state, and it can drop to a wait state where the hypervisor is going, yeah, just hang on a second. And then it can go to a ready, meaning it's ready to run, but there's no available slot in the queue. Or it can go to a co-stop state, meaning, yeah, you got a bunch of CPUs on here. This one's cut ahead quicker, so we got to wait for that one to let everybody catch up. And then it does this, just on, off, on, off, on, off. And while it's running, there may actually be efficiency losses in there. There could be hyper-threaded CPU cores that are not totally efficient. It could be processor power throttling just to save a couple cents worth of power. Not what we want on a SQL server, but whatever. Now, this looks severe, and I know it does. In a perfect world, when this stuff is managed right, this overhead is less than 1/10 of 1%. That's awesome. Done incorrectly, this is your worst bloody nightmare. This could actually be thousands of percent overhead and everything running just super slow. So you got to be real careful with this stuff. Now, to me, since every single thing has to be scheduled, I always ask a basic question. How many CPUs does your SQL server actually need? And most people either go by what the vendor has been given, or they add so many that the SQL server is maybe 3 or 5% busy. Well, that's a waste of licensing. So what we need to do is understand how to right size the allocation. Allocate what you need with reasonable headroom, of course. You're going to reduce the scheduling time. There's a high likelihood that you're going to speed it up by not giving it too many cores, at least not more than it's actually using, and you're going to save money. If you're in the cloud, you can save that money almost immediately, and that's a big deal. So how do we right size? And this, it sounds like a loaded question, but it's really not. Allocate what you need with a reasonable amount of headroom. You can always bump this thing up in the future during a maintenance window. This example right here is literally just perfmon dropped into Excel. This client knew they needed 64 CPUs to make this SQL server run. Do you really think they needed all 64? Heck no. Realistically, they were at only about 30% busy on 8. That was about 21 grand a month I saved them on Azure. That's a big deal. So determine what we need now with headroom. Now, we got to be careful around this stuff. So if you haven't dealt with SQL Server licensing, developer and web edition, whatever, standard and enterprise are where we at. You've got core and server under enterprise, standard, normal stuff. The stuff that I care about, if you're licensing by virtual machine, and this is the cloud model as well, standard or enterprise, minimum of 4 virtual CPUs required for licensing, and then you increase your license packs by 2. If you are on-prem or have a dedicated host in the cloud, if you do not get software assurance with that, this is enterprise only. All the physical CPU cores must be licensed on the host. And the number of virtual machines that you can apply equals in the number of licenses. So if you have a 16-core physical machine, you can put 16 VMs on there. If you get software assurance on there, the number of VMs is unlimited. So if you're on-prem, this is where you want to be. By the way, if you buy your licensing through one of the cloud providers for this stuff, don't buy it yourself and bring it and carry it. Okay, CPUs go a long way in here. Now, I didn't mention this before, but as long as your networking doesn't look like this, you're fine. Now, let's talk about storage queuing instead. Storage performance matters, but what your infrastructure team focus in on and what we as SQL Server pros focus in on are two completely different things. Storage latency, the round trip for something to make it to disk, be hardened, and SQL Server to return. That's what I care about. Your infrastructure team are focused on I/O operations per second, or IOPS. They're looking at higher means better, and they think that the highest IOPS rate storage that they can get is going to give you the best bang for the buck. It's not always the case. Think of it this way. Let's just say you bought a brand new Corvette and the speedometer does 220. Where are you actually going to drive 220? And unless you're Anders, then not that often. But if you're at a light and you need to cut over to merge onto a freeway or something, that 0 to 60 time is what really matters. So really, latency is where I focus in on. I just need IOPS ceilings on my enterprise storage that's higher than what I'm demanding of it. Now, all throughput or megabytes per second is IOPS times the request block size. That's it. So the only thing you really got to worry about with throughput is monitoring your interconnects. So if you're fiber or network attached, just make sure you're not maxing out any of those interconnects. But at the bottom line, latency is what truly matters to all factors of virtual machine performance.
Anders did ask me to correct a slander, and that was that he would never do 220. It's 230.
Gotcha.
And there's a real question that came in here. How do you conceive the trade-off of vCPU versus memory? Like, how do you know which you need, when you need it, how you need it?
That's a great question. There is no magic formula for any of that. Essentially, if you see memory pressure coming from within SQL Server, and don't listen to VM admins tell you you don't need all that RAM, because a lot of times you do. If you see memory pressure, then add more memory. If you see CPU pressure, meaning your CPU consumption rates are just through the roof, or you got things like SOS scheduler yield, CX consumer weights, anything telling you have CPU scheduling pressure from within the database engine, then you need more CPU. They don't always go hand in hand, though. A lot of people will say, well, I need 4 gigs of RAM for every processor that I've got, or 8, or just some ratio in there. It doesn't factor into what the workload is actually doing or how well or poorly designed that ratio actually is. So use the telemetry that comes out of the database engine and use your best judgment there.
That makes sense. And
yeah. I wish I had a silver bullet with that one, but I don't.
Yeah, the one thing I think I would throw in is that Glenn Berry, already mentioned him, his diagnostic scripts include a few that help you discern, do you have memory problems?
Yes.
And also in a lot of cases, tune your queries and suddenly you don't have memory or CPU problems anymore. That can be an issue.
Yeah, unless you're a third-party vended app, and that case, good luck. You can tune around it, but you may not be able to get to the root of the issue. Yeah, a lot of fun. Now, storage media really does matter with this stuff. A lot of infrastructure people don't really grasp how low latency truly matters for us. So they may buy storage with good, cheap spinning disks. They're cheap, but they have high capacity. Nowadays, it's less of a concern. Most of the time, it's either flash hybrid or all flash. It's fantastic for random I/O. The latest generation of the stuff out there is called NVMe, or non-volatile memory express. It's not cheap, but it's ultra fast, and it's fantastic for random I/O. So if you're buying a desktop or a laptop, you're probably going to have an NVMe drive for the at least to boot off of. Servers, we may not be that lucky. So just understand what's actually underneath this, and that gives me an idea of how we can actually start to tune. Now, there can be local storage in some of your physical machines. There may be shared storage on some type of centralized storage like a SAN or a network attached storage unit like a NAS. You may have decentralized storage. You may have hyperconverged storage. And then cloud, you get to kind of pick and choose certain things, but you don't really know what's under there. And I would claim that in most cases, you probably don't need to. Storage performance matters. And here's the problem. So let's just say that you wake up and you're getting disk stall warnings that say, we've got 3/4 of a second delays on our writes, everything's done. And then you pick up the phone and you call your infrastructure team and they say, go back to bed, your writes are fine, blah, blah, blah. You ever have those? I know I have. Well, guess what? You're both right. There's a ton of queues in here. And even if you're in the cloud, there are some things that you can do to work through some of these. A lot of what I'm going to talk about here for the next minute, it's on-prem. The same challenges exist on cloud, but you don't have access to them. So hold on. So when you're on-prem, really when you're in the cloud, but you don't have access to it, this is what's really going on underneath. You've got the hypervisor, you've got the physical machine, you got CPU memory, you got interconnects, you got enterprise SAN with spindles and SSDs and memory and controllers and network adapters. When we start looking at the storage queues, you have a storage queue on a disk in a SAN. You have cache memory, you have controller interconnects, you have switches, you've got physical machines. You've got all kinds of queues going on inside the hypervisor. You've got a queue getting to the controller inside Windows. You've got a controller queue going through that virtual disk as well. Then you've got the storage engine inside SQL Server. Then you've got your individual database queue. Then you've got the data file queue. And all of this is how you work backwards and forward through all these. And that's just one machine. Now multiply it times however many SQL servers you've got. There's a lot of layers in there. If all of these are not set properly, you got to watch out because it'll backfire. The next few slides, if you were on-prem, I'll give you a copy of the slide deck. I want you to take this back to your infrastructure team and talk to them and just say, are these things tuned? If you're fiber connected on-prem, your fiber adapters have a queue depth setting that is probably far too low. It's kind of like you just bought a brand new Ferrari or Corvette or whatever, and it came with square tires. Cisco UCS is the worst offender out there. I love the platform to death. The default queue depth on the thing is 20. That's literally, you bought a Ferrari, and it looks gorgeous in the driveway, and it came with square tires that are filled with concrete. Change the tires. Bump up that queue depth. Now, how high you bump this up depends on the storage you've got. The lower latency storage going from spindle to flash hybrid to flash to NVMe, that tells me how high we need to bump these settings up and do all the testing in the world to go make sure everything looks good. This value is too low. If you're not on Cisco UCS, but you are fiber attached, most of the time the queue depth is going to be either 32 or 64, and most of the time that's too low. If you make this change, check with your specific hypervisor to see if you need to change a driver in there to match the firmware queue depth that you just changed on the physical machine. The VMware specific ones are here. There's equivalent for Hyper-V and all kinds of other platforms out there. If it's network-based shared storage, such as iSCSI, your default queue depth is 128. Depending on your storage array, it may be too low. And this is VMware, this is Hyper-V, it's all of them. Go change that setting, bump it up, do the testing, of course. Now, the next one here is VMware specific. I joke that VMware is the center of their own universe because if you look in the ESXi kernel, a virtual machine and its dependent virtual disks is categorized as a world. Yeah, I can't make this stuff up. If one world exists on a SAN LUN, the queue depth at that host to that LUN is 32, or excuse me, it's inherited from the virtual machine. If more than one world exists on the data store, and it almost always does, the queue depth is now automatically decreased to just 32. It's, once again, too low. There's a document link on the screen here. You can go adjust this. Now, this one's VMware specific. I don't have an equivalent setting for Hyper-V or some of the other platforms out there. Now, if anybody here is hyper-converged, so Nutanix, VMware vSAN, Microsoft Storage Spaces Direct, get rid of the traditional SAN model. And what they did was take a bunch of physical machines, pack them full of hard drives, be it flash or spindle or both, connect them with high-speed networking. Sounds good, right? Now, with software, take those machines and aggregate the storage and then present it back to all the hosts as if it were a SAN. Sounds cool, right? No complexity, life is good, no problem. You still got to deal with metadata management. You still have to deal with where's my data at across these. You have to deal with how to copy data around as it changes. So if any one of these hosts just dies, you don't lose anything. So every one of these has a virtual management appliance to deal with the software-defined storage. On a SAN, you have a controller. You got cache memory. There's processors on there. It's purpose-built to handle all this stuff. In a virtual world like this, with basically fake storage, all of that processing for all this metadata management and compression and deduplication and data copying, it's all done on the same CPUs and the same memory that you do all your CPUs for VMware, for Hyper-V. That's all what your SQL servers are running on. Be careful with this. I'm not telling you not to use this, but if these things are hindered in their ability to get to processor, you can end up with poor performance. And what you've got is a situation where storage latency takes a hit. And my personal red lines for all flash storage is no more than 10 milliseconds for reads or writes. You can see what hyperconverged does. When it's not properly designed or under spec or not properly maintained, you end up with poor storage performance, especially writes. You can see this in ingest storage latency. Now, part of it is because the database engine throws a very large block size workload pattern to a lot of these things. And what I find is that trace flag 1800 will take a lot of these larger block operations and it literally shrinks them to a 4 kilobyte operation. You have more of these, but it might just be worth testing to see if you get better underlying performance, because the underlying layer doesn't have to deal with digging a lot of the stuff out of a larger payload, breaking it down into small chunks, and then dealing with it. Now, one of the other things is how to more widely distribute your database objects. So more data files, more file groups, if you can do that with your application architecture. All this stuff truly matters here. Any questions up to this point?
No questions in chat, although if you do have questions, you should get them in chat, and then we'll go with them.
Go for it. Okay. Item number 5 on here, it's a virtual machine disk presentation. Now, this goes even more to public cloud. Normal stuff. If you're on-prem, hey, give me a hard drive, give me this size, go. If you're in the cloud, give me some data disks, make sure they're this size, go. It's doing the same exact thing. The stuff that really matters on here, the hypervisors, cloud and on-prem, they do disk I/O coalescing, or literally command queuing, not just by drive, but by drive controller. Same thing with the physical machine. You have a storage controller to connect the storage. It does all of this stuff. So controller types. If you are on VMware or Hyper-V, the default is to use the LSI Logic SAS controller. It has a finite queue depth of 32. If you're on Azure, this is what you get, period. If you are on the VMware platform, be it on VMware Cloud or on-prem, you have an option to change your controller type to VMware Paravirtual SCSI or PVSCSI. It has a default queue depth of 64, so literally double the commands can queue up in a registry addressable setting that can go all the way up to 254. Don't do that unless you got a lot of this underlying stuff cleaned up first, or else it can be too high, and it's kind of like you're just pushing backwards on yourself. It's not the most fun. There's also an NVMe controller. I don't recommend using it, largely because if you go to grow a hard drive that's connected to a VMware NVMe controller, you can grow the drive. You don't see the new space until you reboot the VM, which is great when it's 2 p.m. in the middle of the day. You can't reboot a server and your transaction log is filled up. So I tell people don't ever bother using that one. Now, how to assign a disk to a controller. If you're on-prem, you can do this. If you're in the cloud, sorry, you don't have the ability. But what you do is you just say, here's my controller. So in this case, called a virtual device node. And you can map a drive to a controller. So if you're on-prem, you can say, give me up to the max controller count that I have, in this case, 4. So if you're on Hyper-V, you get 4. If you're on VMware, you get 4. You get a queue per controller. So stagger your objects across the available controllers. And I know it sounds easier said than done, but you can do this. So operating system, system database, SQL install, if you want to spread them out that much, put that on one. User database data, park it on one. Transaction logs, park it on a different one. TempDB, park it on a different one. Now it's up to you in these baselines. How do these things get used? And you can go all the way into, what are my hotspots per database, per table, per index if you really need to. And you can start to figure out how to properly spread your items around to get the best possible queue depth. Now I know it sounds crazy. I know it sounds like a ton of work. It's not easy. But once you get the hang of it and get in the habit of it, it becomes better. You can go further if you need to. If you need to have, let's say, a really big database and you want to spread this thing around, if it's a third-party vendor database, you got to tread carefully here. A lot of times they won't let us go do this directly, but what you can do in that case, add more data files to the primary file group, spread this thing around. If you have control over this, think heavily, more file groups, more data files. If you can do that, add more drives, connect them to different controllers, stagger and weight these things equivalent. So you've essentially spread out the workload across more controllers. You get a better queue depth. Life is good. I have a how-to on how to do this and the benefits you get from it. If you have a database with a single MDF file and it's big, spread it around. Please do. The database engine has a storage engine in it. It will help. The queuing at the hypervisor layer gets better. You can multipath to the underlying storage better. It really does matter. Cloud and on-prem, it all adds up. Now, cloud storage in general, it's a lot more abstracted, which gets really interesting. So if you have a VM out there, don't do standard hard drives. They're spindles. May those rest in pieces. There's managed standard SSDs, there's premium SSDs, and basically the storage characteristics tell me that it's just a cheap SATA SSD versus an NVMe drive. There's the Ultra SSDs. I generally ignore those because most of the time you're hitting your virtual machine performance ceilings before you can actually leverage those and really get a lot of speed out of them. If you're on Amazon RDS, Azure SQL Managed Instance, Azure SQL Database, you don't really get the options for this. Now, when you go premium tier versus standard tier versus basic tier, they assign a class of storage based on the tier that you're on. You don't necessarily know what you're getting, but you can kind of interpolate. The more you spend, the faster disks you get. You just don't have that choice. You just say, give me this much space, and they hand it to you. You've also got blob storage for SQL Server backups, which is really cool. I don't need to know the IOPS or the latency characteristics of this. I just need to know, can it handle the kind of throughput that I want to park in here and make it quick, and what's my network connection to get there? You just use it. Now, it all goes back to that comparison between on-prem and cloud. One of the big differences with the cloud is that if you're on-prem, there's performance ceilings at a few places, but most of the time they're not really enforced. It's literally just whoever goes and grabs the IO first gets it. If you're on the cloud, you have a performance cap with every single virtual disk that you assign a virtual machine. So you can see right here, if I'm looking at an Azure P30, it's 1 terabyte. You have 5,000 IOP peak or 200 megabytes a second peak, whichever hits first. Now, realistically, if you format these to a 64K block, divide the provisioned IOP by 16. If you're looking at perfmon, that's the kind of math you need to start evaluating, because you don't want to be hitting these performance ceilings, because all it does is slow everything down. There's burstable IOPS in some of the smaller virtual disks, but the IOPS and the throughput are just so low, it's probably not worth it, except for some small VMs out there. There's caching. Please, please, please do not enable write caching underneath your SQL servers. It's the easiest way to corrupt a database. Read caching, maybe. Definitely not write caching unless it's something like TempDB, but that should probably be on your temporary storage anyway. It's all based on the performance tier and the disk size. What I hate telling people is that you actually need to provision a whole boatload of space just to get the speed that you're expecting. But in some cases, that's all we can do, and they end up spending more than they expected. Now, there are some interesting performance ceilings in here. You can see premium SSDs versus standard SSDs. You generally get more max throughput, higher IOPS. You'll get lower latency as a side effect of all this. Ultra disks, I can hit 4,000 megabytes. But no, you can't. Because when you look at the virtual machine tier, in this case, the DS series, the other one, I can hit 4,000 megs a second. Uh-oh, if I'm provisioning an 8-core 32 gig, my max uncached disk throughput in terms of megabytes per second, 290. Why are you paying for ultra disks? You don't need to. It's a real challenge because you've got these performance ceilings that you got to manage both at the virtual disk level and at the virtual machine level. There's IOPS ceilings, there's throughput ceilings. It's cumulative for all of the virtual machine disks out there, and that's a real challenge. Now, as long as you manage this, it may be okay, but keep an eye. This is where that baseline comes in so handy, because if I know when I'm on-prem and I'm looking at the cloud and I need to turn around and get high throughput, how much do you actually have to project so that you're spending on this stuff? It's not fun. Now, there are some alternatives. Azure NetApp Files, or ANF, gives you an SMB share, and SQL Server does work with SMB. You gotta change your mind a little bit on it, but it does work. There's also one that I like personally. It's called Silk. Think of it as a cloud SAN. That's it. You basically spin up a virtual machine. You don't connect any managed disks. You connect to it over the network. So instead of these really low IOPS and throughput caps, you're now limited to your network adapter throughput, which is a lot higher. It's actually pretty cost effective. So if you have really high throughput requirements for a lot of the stuff, I don't get a thing for talking them up. I just use the heck out of it. Give it a try. Take a look at it. If you want, I can make the introduction over there. I do a little bit of R&D with them. Again, I don't get a cent for talking them up. I just really like it. Now, that's the 5 layers of tuning that I go through. Cloud, on-prem. Once you start finding the nuances with each of these, you can drill into each of those areas and really, really get even more out of it. But if you can cover those 5 areas, it'll get you 95% of the way there. And most of the time, that's good enough. So you start at the lowest possible thing that you've got, your SAN or your enterprise storage. You hit those interconnects with those QDAPs, if accessible to you. You hit the physical server. You tune whatever virtualization you can, and then you start hitting the database, where now it's SQL Server file groups and data files and spreading the workload out. And then at that point, then when you start query tuning, when you start index tuning, when you start tackling all this stuff, everything underneath is cleaned up. So now you're not going to be held back by all the bottlenecks that are present in all these platforms. Now, any query tuning, any index tuning, you're going to end up with a lot better result. And that goes a long way. So just like I always say, anybody blabbing on, presentations like this, don't trust anything they say. Question everything, and please always test anything any of us tell you to make sure it actually applies to your environment. But with what I've shared here, these are things I do this day in and day out. It will make a positive gain. How much depends on your environment and how badly it's tuned right now. And I'm not blaming anybody for that. There's a lot of really stupid defaults in a lot of these pieces. So do some testing. Thank you all for taking the time today. I will be sending the slide deck out to Kevin, and that way, if there's any questions or if anybody wants to share this with any of the systems folks in your companies, feel free. I made them kind of text and slide heavy, so that way you could kind of use it as a checklist. But let's open the floor. Are there any questions or thoughts?
Yeah, there are a couple of
Sweet.
them in here. So
Cool.
The first one is, how much of all the things that you walked through can be controlled when running VMs in Azure?
A lot of it, actually. Your virtual machine count, you can select the processor type that is going to give you the best bang for the buck. The spread of your virtual disks will go a long way in there. Same thing with spreading your SQL Server objects around. If it's a really big virtual machine and it's running Enterprise Edition, you can actually do things like, and I didn't mention this in the presentation, but you can do large memory pages. That will actually help you make the most of that platform and all the memory addressable space and get a better bang for the buck there. And then, with storage itself, being able to pick the type of disks, monitor those ceilings, but let's say premium SSDs instead of standard, or save the money off of Ultra or provisioned IOPS drives, those sort of things. You can control more than you might think. You can even turn off hyperthreading. You can actually reduce the exhibited cores, but keep the amount of memory if you find you need more RAM. Azure calls them constrained core virtual machines. They really do come in handy. So you can control more of it than you might think. You just have to know where to find those knobs.
Okay, makes sense. And we had a couple people in chat mentioning, yeah, Ultra is not good for the cost for disks.
Exactly.
Also,
Yep.
There's another person who mentioned that in their workload, non-hyper-threaded VMs were working better for them than hyper-threading.
Yep.
And not like 48 core non-hyper-threaded and 48 core hyper-threaded, but the 48 versus 96. So
yep. And by the way, if you turn off hyperthreading for a SQL Server and you bring your own licensing, you just cut your SQL Server bill in half. Think about that.
Sure.
Yeah, on Azure, it's PowerShell. On Amazon, it's literally in the GUI. And if you bring your own licensing with the hybrid benefit, you just cut your licensing in half and made it equal or faster. That's a lot of money.
Yeah, seems like a good way to do it.
Yeah.
What is your favorite way to abuse ephemeral storage?
By abuse, what are you referring to there?
That's a good question.
Because you can do synthetic storage tests all day long. You can restore a SQL Server on database on top of itself over and over and over again and crush it. You can have all kinds of fun with that.
Yeah. So for running things like TempDB, would you recommend that on the Azure ephemeral storage?
Yeah. As long as your TempDB space that you need for your workload will fit on that temporary storage, absolutely.
Okay. And there was a question in here. So why would hyperthreading be a bad thing?
Great question. I'm going to be a little long-winded on this one. So what a hyper-threaded logical CPU core is think of it this way. When a processor receives a command, it goes, yep, here's my command. I've now compiled it. It's ready to go. Okay, well, I need this block of memory. So it sends the command to get the block of memory. Now it just sits here and waits, twiddles its thumbs. Okay, now I got the memory. Oh, crap. Now I need this object from disk. So as I go back down to disk, and it's just sitting there spinning and waiting. There's a lot more to it than this, but think of it this way. The percentage of clock cycles that are not being used in that pass are presented as another logical core. So think of it this way. If I got a physical CPU core right here that's 70% busy, in theory, that's 30% that's over here. If the database engine isn't aware of this, it's going to try to use these in a 50-50 ratio. But this guy over here, this logical core, isn't fully powered. It's not as fast as the primary core. And because the operating system now has to understand how to park the command on that core or manage parallelism across multiple cores, but some of them aren't running as quick as the other, it can actually slow things down. In a physical server, I say leave hyperthreading on, but ignore that it ever existed. And in some workloads, turning it off makes it quicker. Most of the time, nothing really happens. In a virtual environment, all the hypervisors out there rarely touch hyperthreaded cores. It's kind of a misnomer. So I usually leave hyperthreading on, knowing that the hypervisor will rarely ever go there. In my personal opinion, take the company logo off. Presenting hyperthreaded cores to virtual machines is one of the biggest financial scandals of the 21st century. I claim that a hyperthreaded core is good for about 15% of a regular core. If you're paying 100% more SQL Server licensing for hyperthreading, and at best you're at 15%, you're just burning money at that point. The problem is you'd have to buy your own licensing and apply it in order to actually be able to leverage that. Not the most fun. Now, occasionally I find workloads that benefit from hyperthreading. Most of the time, it's either just a negligible difference or it actually regresses just a little bit. So when I'm looking at cloud virtual machines, it bothers the heck out of me. The hyperthreading is on. And if you look at perfmon and you look at the per core charts, you can actually see hot and cold bands in there of where hyperthreading has been detected by the database engine, and it tries to steer clear of it. So the way I look at it, hyperthreading, people treat it like it's a full CPU. It's not. If you understand this distinction and you do some testing and you find that your workload benefits from it, great. Most of the time, you're not going to see an improvement, but you're paying double. That's why I don't like it.
That makes sense. And if there are any other questions, chat, now is your opportunity. Let's get them in.
Sweet. It's been fun.
Yeah, we certainly appreciate you taking the time this evening to enlighten us on some performance tuning options available to us in the virtualized space.
You're welcome. The stuff is fun. And most of the time, VM admins don't know SQL Server internals, and DBAs think this is not my job. But you need a basic understanding of this stuff so you can talk with the VM team, make sure everything lines up. Unchecked, untuned, the stuff is good for a 30, 40, 50% performance hit. And that's not good. I mean, that means you're spending more on licensing, your end user experience is poor, yada, yada, yada. Tune this stuff, squeeze the most out of it. I know how expensive this stuff is. Get the most out of it. Get out of your comfort zone just a little bit. Get your hands dirty with some infrastructure, cloud or on-prem, and it goes a long way.
All right. Would love to have my VM guys watch this. Well, yeah, there's potential. There's a potential opportunity there.
Yeah. Yeah. And again, if anybody's watching this and you run this by your infrastructure team and they have questions, let me know. Again, I'm happy to jump on the phone and talk to them about it. And there's absolutely no marketing or strings attached. I don't work like that. But if I can help make your life better by talking to them, I am happy to do so. So let me know. And if anybody has time to digest this stuff and has any questions after the fact, contact info, if you just go out to either heraflux.com or davidklee.net, drop your contact info in the contact me form, and I'll be happy to get back to you.
All right, and it looks like no more questions. So,
Cool.
Wow, we're P to V from 15-year-old hardware.
Whew. Yeah, if you're doing P2V, as soon as you get done with the P2V operation, get rid of all the hardware junk that came along with it, like storage controller software, network adapter teaming, or all that kind of stuff. If you can do that, then just run a really good integrity check when you're done. It'll probably be okay. But at 15-year-old hardware, is your OS even supported anymore? I hope that it is.
Yeah, two-phase approach. Yeah, that's.
Yeah, I mean, getting old equipment retired, even if you have to just drag it along, if the equipment's starting to crap out, by all means, get it off of the old equipment. If it's cranky and about to die, don't wait until it fails. Get it virtual, and then deal with it at that point.
That's a Windows Server 2012, which, as Radio Guy mentions, that runs out of support on premises in October. You can actually if you go to Azure, they will support Windows Server 2012, I think, for another 3 years.
Yeah.
Or just upgrade to a version of Windows that was released in this decade.
Yep. Yeah, get something current. I mean, quite frankly, we're seeing a fair amount of this. If you're on unsupported hypervisors or operating systems or even database engine versions and you get hit by a security incident, they're going to use that as a way out to not cover you and validate your insurance policy. So be careful with that.
Yeah, so all that's phase 2, and best of luck in both phases.
Definitely, yeah. There is a SQL Server on VMware. So is it VMware or is it Hyper-V, or what's your platform?
May take a moment. There
Yeah,
is a little delay between when we're talking and when folks get to hear it. It's like 10
no
seconds,
rush.
15 seconds.
Yeah,
VMware.
that's okay. Okay, if you're on VMware, the thing that I would say is look at the best practices guide that's publicly available for the version of VMware you're moving to. I'll do this for 2 seconds. I've been helping write and edit them for a long time now. Follow that guide, because when you're done P2Ving, there may be a couple of things that you need to do right when you first turn it on, like change a network adapter type. Those paravirtual SCSI adapters will not be added as part of the default P2V process. So those are all things that you can retrofit very soon after you do that P2V and squeeze the most out of it to really help make sure your migration efforts go quick.
All right. And
Cool.
got a thank you, very informative presentation. Fully agree. Much
You're welcome.
appreciated. And I think what we're going to do is, barring any last second questions sneaking in at the deadline, we're going to round things out for this evening and wrap it all up.
Cool.
So remember, everybody, next week we do have our main meeting. 2 weeks from now is our BI and data science meeting. There is a question. So what do you and Glenberry disagree on?
um, Not much, to be frank. I know he loves local attached storage. I personally don't. Um, I want SAN even at the expense of a small amount of speed, just because I don't like single points of failure. Other than that, I think we're completely on par with CPUs and network adapters, all that kind of jazz.
All right.
I'll have to ask him though. That's funny.
So with that, I think we'll make that the last question.
Cool.
Finally, contact info. Let me drop a link in chat. You can go to heroflux.com,
Mhm.
and in the contact box in there. So just dropped a link there for everybody in chat if you are interested. And with that, we're going to wrap it up for today. We
Sounds
appreciate
good.
you coming in, David. Much obliged.
You're
And
welcome.
for everybody else, until we see each other again, take care.
Awesome. Thanks, everybody.